Welcome dear student and Jai Swaminarayan. Today in this video, I will start your new chapter number 9, Mechanical Properties of the Solid. Dear student, we know that there are three different state of the matter, solids, liquids and the gaseous. In this chapter, we will discuss about the properties of the solid. General properties of the solids, you know that. In this video, in this chapter, we will discuss about the mechanical properties of the solid, strength of the solids. In this chapter, we will also discuss about the how the strength of the solids depends on which parameter, how the different types of the solids react with the different type of the forces. So dear student, let us start with the general properties of the solid. So dear student, we know that there are three states of the matters: solid, liquid and gaseous. In this chapter, we will discuss about the properties of the solid, liquid and gas, commonly known as the fluids. Fluids are a matter that can flow. The matter that can flow is called the fluids. So liquid and gas are considered as the fluids that we will discuss in the next chapter, properties of the fluid. So let us start with the solid. So general properties of the solid. Solids have a finite shape and the finite volume. Solids have a finite shape and the finite volume. Why the solids have a finite shape and finite volume? Because the constituent particles of the solids are very close to each other. The intermolecular distance in the solid are very small. Here the constituent particles of the solids are very close to each other. We know that the constituent particles like molecules, atom, ions. So in the solid, the constituent particles are very close to each other, right? The intermolecular attractive force in the solids are very large. The attractive force between the molecules, attractive force between the ions, attractive force between the atoms are very large compared to the liquid and gas. So here, due to the constituent particles of the solids are very close to each other, intermolecular attractive force is very large compared to the fluids and the gas, so that the solids have a finite shape and the finite volume. Now in the solid, these constituent particles, what are the constituent particles? The constituent particles are the particles which forms the matter, right? So here the constituent particles may be a molecules, may be a ions, may be a atoms, right? So how these constituent particles are arranged? According to the arrangement of the constituent particles, the solids are classified into three categories. Which three categories? Crystalline solid, non-crystalline solid and semi-crystalline solid. So understand, according to the arrangement of the constituent particles, the solids are classified into the three categories. First one is the crystalline solid, second one is the non-crystalline solid and third one is the semi-crystalline solid. So let us understand, what do you mean by the crystalline solid, what do you mean by the non-crystalline solid and what do you mean by the semi-crystalline solid. So here crystalline solid, if the arrangement of the constituent particles are regularly spaced pattern, for example copper. So if you see the unit of the structure, crystalline structure of the copper, you will find that the arrangement of the constituent particles it may be a molecule, it may be a atom, it may be a ion, or it may be a positive ion. So the arrangement of the constituent particles are regularly spaced pattern like a array, right? So this type of the solids are known as the crystalline solids. So if the arrangement of the constituent particles are regularly spaced repeated pattern, the crystalline solid, the solids are called the crystalline solids. For example, if you consider the crystal of the copper, right, you will find the regular spaced array. The molecules of the copper or atoms of the copper are arranged regularly spaced pattern. So these type of the solids are known as the crystalline solid, right? You will see the crystal of the copper, you will find in each corner of the cube one Cu atom is there. So the it forms the crystalline structure. So the study of the crystal of any matter, that is the crystallography, right? So here the crystalline solid, what do you mean by the crystalline solid? The if the arrangement of the constituent particles are regularly spaced pattern, the solids are called the crystalline solid. The crystalline solids are further classified into the four categories: molecular solid, covalent solid, ionic solid, and metallic solid. So if the constituent particles are a molecule, the solids are called the crystalline solids are called the molecular solid, right? If the constituent particles in the crystalline structure, if the constituent particles are a atom, the solids are called the covalent solid. And if the constituent particles in the solid is a ion, positive ion and the negative ion, the solids are called the ionic solid. And if the constituent particles is a positive ion, the solids are called the metallic solid, right? So understand all the four types of the crystalline solid. What do you mean by the crystalline solid? If the constituent particles of solids are regularly arrangement of the constituent particles of the solids are regularly spaced pattern, the constituent the solids is called the crystalline solid. The crystalline solid are further classified according to the constituent particles in the four categories: molecular solid, covalent solid, ionic solid, and metallic solid, right? If the constituent particles in the solid are a molecule, the solids are called the molecular solid. Molecules are con connected with the covalent attractive force, right? So this type of the solids forms by the van der Waals attractive force or dipole attractive force. Molecular solids are formed. Second one is the covalent solids. So if the constituent particles are atoms, the solids are called the covalent solids. The atoms are make a covalent bond with the neighboring atoms by sharing a electron of the one atom to the electron of the another atom, and the solids are formed, that is called the covalent solid. Third one is the ionic solid. If the constituent particles in the solids are a positive and the negative ion, right? For example, NaCl, right? Na plus positive ion, Cl minus negative ion. So this positive ion and the negative ion is strongly attracted with the electrostatic force, attractive force, and the solids form. This type of the solids are known as the ionic solid. And last one is the metallic solid. In the constituent particles in the metallic solid are a positive ion. So atom lost the one electron and it becomes the positive ion, and this positive ion forms the regularly spaced arrangement at the specific lattice point, right? So, and the solids form. This type of the solid is known as the metallic solid. So dear student, understand what do you mean by the crystalline solid and what are the types of the crystalline solid. Next one is the non-crystalline solid. So what is the non-crystalline solid? So if the arrangement of the constituent particles are not regular, right, the solids are called the non-crystalline solid. The arrangement of the constituent particles is a different at the different area or different crystal. The solids are called the non-crystalline solids. For example, wooden, crystal of the wooden, we cannot find the arrangement of the constituent particles is a regular. Or the example of the non-crystalline solids are the amorphous solids, glassy solids, right? So in these glassy solids or amorphous solids, the arrangement of the constituent particles are not regular, right? And third one is the semi-crystalline solid. In semi-crystalline solid, the arrangement of the constituent particles are in the some portion, the arrangement of the constituent particles are crystalline, and in the some portion, the arrangement of the constituent particles are non-crystalline. This type of the solid are known as the semi-crystalline solid, right? For example, polythene, right? The example of the semi-crystalline solid is a polythene. So dear student, understand what do you mean by the solids and what are the types of the solid? Crystalline solid, non-crystalline solid, semi-crystalline solid, right? If the arrangement of the constituent particles are a regularly spaced repeated pattern, the solids are called the crystalline solid. If the arrangement are not regularly spaced pattern, the solids are called the non-crystalline solids, and the arrangement of the solid constituent particles in the solid are crystalline as well as non-crystalline. The solids are called the semi-crystalline solid, right? The crystalline solid, according to the constituent particles, the crystalline solids are classified into the four categories: molecular solid, covalent solid, ionic solid, and metallic solid. In the more detail about this molecular solid, covalent solid, ionic solid, and metallic solid, you will study in the chemistry, right? So no need to discuss more detail about this type of the crystalline solid and the semi-crystalline solid or non-crystalline solid, molecular solid, that all the things you will study in the chemistry portion. Now the important point in this chapter is that what are the effect of the force in this type of the solid. So when we applying a force on the solid, what the effect we observe? In the previous chapters, we were discussed about the effect of the force. By applying a force on the body, right, the body can change its position. From body can be in the motion from the rest position, we can change the direction, we can change the direction of the object, we can change the direction of the body, or we can stop the motion of the body. So effect of force on the body is that, right? So from by applying the external force on the body, we can change the state of the body from rest to motion, from motion to rest, or we can change the direction of the motion of the body. Now in this chapter, we will discuss about the another effect of the force on the body. When we applying a force on the body, we can change the shape of the body, we can change the dimension of the body, right? So if we applying a force on the body, we can change the shape of the body, we can change the dimension of the body. And if we remove the external force, right, somebody can retain its original position, right? As you know that if we consider the rubber band, and when we applying a force on the rubber band, its dimension, its length is increasing, but if we remove the force, right, it will retain its original position. So dear student, by applying a external force, we can change the shape and the dimension of the body. That's why this type of the force is called the deforming force. By applying a force, deforming force, we can deform the solids, right? We can deform the solid. So this type of the external force is called the deforming force. And when we remove the deforming force, the body will retain its original position. And the property by which the body will retain its original position is called the elasticity, right? So in this chapter we will discuss one important mechanical property of the solid, that is the elasticity. So what do you mean by the elasticity? That is the effect of the force. When we applying a deforming force to the body, the shape and the dimension of the body will be changed, right? And when the deforming force is removed, the body will retain its original position, its original configuration, right? So not all the type of the solid. When we applying a deforming force on the solid, the shape and the dimension of the body will change different in the different body, and the retainity of the body, or when we remove the deforming force, right, applied on the body will retain its original position. That is different in the different case. If we applying a deforming force in the rubber band, or if we applying a deforming force in a steel ring, right, same amount of the force is applied in both the body, the re- regaining of the original position, that is different in both different body. So the property of the body by which the body will regain its original position, its original size, its original shape, that is called the elasticity, right? And the solids are called the elastic solid. So that is the important definition of the elasticity. What do you mean by the elasticity? The property of the body by which the body will retain its original configuration, that means it will retain its original size and shape, is called the elasticity, right? So that is the important property. This one is the important property of the solid. What is the important property of the solid? What do you mean by the elasticity? Understand or not? So what do you mean by the elasticity? Elasticity is the property of the solids. We can say that the elasticity is property that can seen only in the solid, right? The property of the solid body by which the body will regain its original configuration by removing a deforming force, right? Or if we applying a deforming force, the dimension of the body, the shape of the body will change. And if we remove the deforming force, the body will regain its original size and shape. And this property is known as the elasticity. The property of the body which the body will retain its original configuration by removing a deforming force is called the elasticity, right? So and this type of the solids are called the elastic solids, you know that. So by the property of the elasticity, the property of the elasticity is different in the different solids, and by the property of the elasticity, the material or solids can be classified into the three different categories. Which are the three different categories? Perfectly elastic material, or we can say that the perfectly elastic solid, perfectly non-elastic material, or we can say that the plastic material, or partially elastic material. So by the property of the elasticity, the material can be classified into the three different categories: perfectly elastic material, perfectly non-elastic material, or we can say the perfectly plastic material, and partially elastic material. So what do you mean by the perfectly elastic material? Let us see. When the deforming force is removed and the material can retain completely its original configuration, original size and original shape, then the material is called the perfectly elastic material. When the deforming force is removed and the body will completely retain its original position, its original configuration, then the body is called the perfectly elastic body. So when the deforming force is removed and the material retain its completely to its original configuration, then the material is called the perfectly elastic material. For example, vulcanized rubber, elastic rubber. You know that when we applying a deforming force to the elastic rubber, its dimensional will change, right? But if we remove the deforming force, it will retain its original position, right? Completely original position. So this type of the material is called the perfectly elastic material, right? Understand? Now what do you mean by the perfectly plastic material, or we can say that the perfectly non-elastic material? So when the deforming force is removed and the material which does not retain completely to its original configuration, the material will does not try some amount of to retain its position, original position, then the material is called the perfectly non-elastic material, or we can say that the perfectly plastic material. So when the deforming force is removed and the material will not try to retain its original position, some, right, it cannot retain its completely original configuration, then the material is called the perfectly non-elastic material, or we can say that the perfectly plastic material. So dear student, understand what do you mean by the perfectly elastic material and perfectly non-elastic material, or we can say that the perfectly plastic material. And third one is the partial elastic material. So what do you mean by the partial elastic material? When the deforming force is removed and the material will retain its original configuration but not 100%, right? The material will retain its original position, but it will not come into completely original position, right? Then the material is called the partially elastic material, right? It will retain its original position, it will try to retain its original position, but not completely. So this type of the material is known as the partially elastic material. So according to the elasticity property, the material can be classified into the three category: perfectly elastic material, perfectly non-elastic material, and partial elastic material. So what do you mean by the elasticity? The property by which the body will retain its original position, the property by which the material will retain its original position, the property is called the elasticity property, right? And according to the elasticity property, the material can be classified into the three different category: perfectly elastic material, the material will retain its completely original position, this material is called the perfectly elastic material, or the body is called the perfectly elastic body, right? The material will which does not retain its original position, it will not try to even uh, retry its original position, right? It will not try to regain its original position. This material is called the perfectly non-elastic material, or we can say that the perfectly plastic material. And the third one is the partially elastic material. So when the deforming force is removed, then the material will retain its original position, but not a completely, it will not retain completely its original position. This type of the material is called the partial elastic material. So now two important from point from this one is that, right? So when we apply the deforming force on the body, the dimension of the body will change, and when we remove the deforming force, the applied force on the body, it will try to retain its original position. Why it will try to retain its original position? With the help of the restoring force, right? So what do you mean by the restoring force? That is the important point, right? What are the two important points of the chapter? right? First important point of the chapter is that when we apply a deforming force on the body, the dimension of the body will change, right? And when we remove the deforming force, applied deforming force, the body will retain its original position. Why? Because of the restoring force produced in the body, right? So what do you mean by the restoring force? So let us consider this type of the thin rod, elastic, made up of the elastic material, and when we applying a external force F on the both the end of the elastic rod, the length of the rod is increases. At the same time, the force will produce on the intermolecular force will produce in the material in the opposite to the external force, and this force is called the restoring force. The restoring force is produced. So when we applying the external force on the body, the restoring force will produce on the body, which try to retain the body in its original position. So restoring force is a force by which the body will retain its original configuration. Restoring force, remember dear student, restoring force is always opposite to the external deforming force, right? So if we applying a, so dear student, let us consider this type of the road, and if we applying the external force in this direction, right, the length of the road is increases, and at the same time the restoring force is produced in the opposite direction of the external force that will try to retain its original position. So here the restoring force is always opposite to the external force. So in this role, the restoring force produced in the molecules in the opposite direction of the external force, and if we remove the deforming force with the help of this type of the restoring force, the body will retain its original position. If we if we consider the spring, and if we apply the tension force on the string, the length of the string is increased, right? Or if we consider a spring, right, if we apply a tension force on the spring, the length of the spring will increase, right? But at the same time, restoring force produced in the spring, and due to this restoring force, the spring will try to regain its original position, and this restoring force we can experience by compressing a spring by our fingers. If we compress a spring by our fingers, right, we can experience the external force, that is outward direction, exerted on our fingers, right, that is exerted in our fingers, right, that we will experience. And due to this restoring force, the spring will try to regain its original position, and this force is called the restoring force. So dear student, understand what do you mean by the restoring force? The restoring force is a force by which the body will regain its original position. The body will try to retain its original position, and the restoring force is always opposite to the external force, right, external deforming force. The restoring force produced in the body is depends on the type of the body, it depends on the external force that we will discuss later on in this chapter. So these 2 points is important in this chapter. When we applying a deforming force on the body, the dimension of the body is changes, and the change in the dimension is measured by the physical quantity called the strain, right? And when we remove the restoring force, the body will regain its original position, and this regaining capacity of the body can be measured with the help of the physical quantity that is called the stress, right? So what do you mean by the stress and strain, that we will discuss in the next video. So dear student, keep watching my video.